Okay, now predicting the product of electrolysis. One of the application of electrolytic cell is doing electrolysis. What is electrolysis? So electrolysis is a splitting of a substance by the input of electrical energy and is open to decompose a compound into its element. Right. Okay, for example, electrolysis of water, right, producing hydrogen gas and oxygen gas. So from H2O, right, it splits into its element, hydrogen and oxygen. Okay, so the electrolyte in electrolytic cell can be the pure compound, a mixture of salt, molten salt, or aqueous solution of a salt. So for us, we focus on pure compound, such as a molten salt, right, and then aqueous solution of salts. What's different between the two? Between the two electrolyte when we do electrolysis? Okay, electrolysis of pure molten salt. Okay, this is pure molten salt. If the salt is pure, so predicting the product is straightforward. So the cation will be reduced and the anion oxidized. Okay, for example here, electrolysis of molten calcium chloride. So this is pure. So you have calcium ion and chloride ion. So calcium ion is reduced, right, at the cathode, right, to form calcium solid, and chloride ion is oxidized to form chlorine ion. So here you can see this is the overall. So calcium is prepared industrially this way as several other active metal. So what if we do electrolysis on salt solution? Okay, electrolysis of aqueous salt solution and the effect of overvoltage. Okay, so you have in aqueous solution, you have mixture of ion and water. So we have to compare the electrode potential of the ions and the water to predict the electrode products. Okay, predicting the electrode products. When two half reactions are possible at an electrode, so then which one occur? They have to choose, the electrode have to choose. Alright. For the cathode, the reduction with the less negative or more positive electrode potential occurs. Okay. Whereas at anode, the oxidation will with the less positive or more negative electrode potential occurs. Alright, for example, what happened, for instance, when a solution of potassium iodide is electrolyzed? Potassium iodide solution. Okay, we can see here, the possible oxidizing agent are K plus and H2O. Alright, for K plus, undergo reduction, this is the value. Alright. Negative 293. For water, reduce, right? This is the equation and reduction equation, and the potential is negative 0.42. So now it is between negative 293 and negative 0.42. So the less negative, the factor is, you look, the less negative electrode potential for water means that it is much easier to reduce than potassium. So, what form at the cathode? Hydrogen form at the cathode. Alright. Okay, what about at anode? The possible reducing agent are iodide ion and water. Their oxidation half reaction are follows. Okay, you can see iodide form iodine, H2O form oxygen. And the value is here, 0.53 and 0.82. Okay. The less positive electrode potential for iodide ion means that it is easier to oxidize than water. So iodine form at the anode. Less positive mean easier to oxidize. Okay, but guys, I want to tell you that predicting product from a comparison of electrode potential are not always the actual product. Okay, that is a phenomena we call effect of overvoltage. The effect of overvoltage. This is happen when involving gas to be produced. Okay, for gas to be produced at metal electrode, additional voltage is required. Means you have to add additional voltage to the potential reduction potential given. This increment above the expected voltage is called overvoltage. Alright, it is around 0.4 to 0.6 volt for hydrogen or oxygen to form, and this is due to the large activation energy required for a gas to form at the electrode. Okay, Overvoltage is a major practical significance. Okay, for the case of production of chlorine from concentrated sodium chloride solution, water is easier to reduce than sodium ion, right? So hydrogen form at the cathodes even with overvoltage of 0.6 volts. Sodium ion, this is the reduction value. So sodium ion, right, to reduce become sodium, the voltage is the reduction potential is negative 2.71. For H2O to reduce to form hydrogen, it is negative 0.42. This is from the reduction value. However, okay, even with overvoltage, we add with overvoltage because for the hydrogen to occur for this process, right, and this industrial production, it is indeed for hydrogen to form at the cathodes, it needs extra around 0.6 volt. So that means it's around total here, you have to plus negative 0.6 volt, is around negative 1 volt. So here, since the value still far, right, the less positive is chosen here, so still hydrogen is produced. Whereas at the anode, alright, electrode have to choose either hydrogen, water or chloride ion. And in this case, you can see, right, for reduction potential for water to oxidize, okay, oxidize and form oxygen, it is 0.82. With overvoltage, it is around 1.4 volt. Whereas for chloride ion, it is 1.36 volt. Here, oxidation, it chooses less positive. So when it chooses less positive, so with overvoltage, for the case to form oxygen at the anode, therefore chloride does produce at the anode. Right? Okay. And overvoltage of 0.6 volt for oxygen make chlorine the product that is easier to form. Keeping that, okay, you have to keep that the concentration of the chloride ion high also favor in its formation.